The galvanic or voltaic cell is the most easy and fundamental cell to understand. Let's take a look at this animation to see how this cell produces a voltage and current flow. It all starts with two materials, zinc atom and copper ion. The zinc atom always wants to lose 2 electrons. Only when it loses 2 electrons does the zinc atom become stable. However, in order to achieve stability, the copper ion wants to accept 2 electrons. Therefore, if we connect them together through a conducting cable, there will be 2 electrons flowing through them. If we can produce more such zinc atoms and copper ions in a sustainable way, then we will be able to achieve a continuous flow of current through the connecting cable. Let's see how we can achieve this. To produce copper ions and zinc atoms sustainably, let's use a copper sulfate solution, which is composed of numerous copper ions and a zinc metal bar, which, as the name implies, contains a lot of zinc atoms. The copper ions in the solution are starving for electrons. If we connect the solution and the metal bar together, then the zinc atoms in the bar will want to donate their electrons. But after donating, the zinc is transformed into ions and ions cannot stay in a metal. So we'll have to introduce another aqueous solution around the zinc metal bar to accommodate these new zinc ions. Now the electrons flow through the circuit, generating electricity, and the copper ions receive them. Once received, the copper ions become atoms. To accommodate these new atoms, we need a copper metal bar. This unique arrangement will produce a voltage and electron flow. However, there is an issue. You might have noticed that in the course of this process, positive charges are accumulated on the left side and negative charges are accumulated on the right side. As these charges build up, they block the journey of electrons. Here you can clearly see how the built-up charges impede electron flow. Therefore, proper measures must be undertaken to ensure that the electron flow is continuous. A simple solution for this is the salt bridge. The salt bridge is an aqueous solution with a lot of Na+ and Ci- ions inside it. This bridge is blocked at both ends with cotton material. However, this cotton material is capable of conducting the Na+ and Ci- ions. If the charge outside of the salt bridge is positive, then negative ions will get out and vice versa. What exactly happens when the salt bridge is introduced in between the chambers? The excess positive charges on the left side will obviously attract the negative ions inside the salt bridge. These ions will leak out and neutralize that region. The exact opposite process will happen on the right side, and there also the accumulated charges will get neutralized. In short, the introduction of the salt bridge made the voltage and electricity production sustainable. The cell we have just created is known as a galvanic or voltaic cell. You can observe that over time the zinc metal bar erodes as it loses zinc ions, becoming thinner and thinner. The exact opposite happens on the copper plate side, which becomes thicker. The galvanic cell will continue its operation until the zinc is completely depleted or the ions in the salt bridge have been completely exhausted. We hope you have enjoyed this video and that it gave you a clearer understanding of what a voltaic cell is and how it works. Thank you for watching.